Hello and welcome to NARC Live on Wednesday the 23rd of October 2024. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7RP. Lovely to be back. On tonight's show, Bob Henderson, 5B4AGN, live from Cyprus on LC filters in multi-transmitter installations. We have club news and views from you, and also news of other events coming up at Christmas. And we find out what on earth this was or is. You've still got time to enter. Had some entries by email, but do drop us a line on either Facebook Live or BATC and we'll read your answers along with everybody else's. First, I have some sad news. Dave Dawson, G0ELJ, is silent key. He's not often seen at club events, but was a regular contributor to the Monday Night Net and other VHF conversations and nets. I can't claim to know him well myself. I met him actually ironically at Michael 2E0SZP's funeral a few months ago. But one of his radio friends, David Cook, 2E0JGV, sent me these words and I thought they were appropriate to read. David says, "Shocked and saddened to hear the loss of Dave, G0ELJ. He was my Morse classmate when I was first licensed in January 2021. We had many classes together and became known as the two, sometimes three Daves, when 2E0DBS joined us. Had some great chats afterwards, encouraging each other to keep going. Interestingly, checking our log, our last lesson together was at the end of February 2023, run by Chris G4CCX, who had to cut the lesson short because of his illness, and now of course he's also silent key. David would like to think that they are both now rattling out QSOs together. Dave's distinctive accent was of course immediately recognisable to all and became a regular attendee in the Monday night social. Always an absolute pleasure to chat with and will be sadly missed by many fellow club members." That's from David, 2E0JGV. It was not Dave's wish to have a funeral, but I have sent a Norfolk Amateur Radio Club sympathy card to his family and wrote the names and call signs of the most regular contributors to the Monday Night Net, which were the people who were there this last Monday and also others that we know regularly join the net. Dave Dawson, G0ELJ, now sadly silent key. Now, it isn't that long before that C word, that Christmas dinner, Christmas word rather, and we always have a Christmas dinner and party, and that has already been arranged now for Wednesday the 18th of December. Tammy's got a slide here to share with you. Now, we have put this on the website. It's on the top of the website at the moment, and it's also in our newsletters, as is the booking form. There's the main details there. And the booking form, looks like the top of the booking form really. There are all the details that you need. It is the booking form, yes. A lovely three-course dinner, lots of choices. You don't just have to have the traditional roast. There's many other choices as well. It's a private room just for Norfolk Amateur Radio Club, and it's just £15 a head. The club is subsidising it by about £2.50, I think. So it's a good three-course meal for £15. You just need to buy your own drinks on the night. And arrival and drinks from 6:45 with dinner served from 7:30. Now I'm organising this for the club and I really would appreciate it if you could book as soon as possible because it just stops me getting worried. Last year we had 70 people and I'm sure we'll get a lot this year as well. I have given an undertaking that we'll have minimum 50 for this room to be our own, but please don't leave it till the last minute. I know that seems an awful long while away. The deadline is the 27th of November, Wednesday the 27th of November, which is probably best part of 5 and a bit weeks away. But I would really appreciate it if you can book. So you can book online. You can download a copy of the PDF, which actually came out in today's or yesterday's newsletter and last weekend's newsletter. You can print that out, fill in the details, send it to me, and then pay the club by backs, or You can do it in the traditional way if you wish and come to a club meeting, like next Wednesday. There's printed forms there. You can complete them there and then and put the cash in an envelope if that's what you prefer, and put your name and call sign on the envelope. So there's lots of options, and you can even pay by PayPal. Details of all of this are on our website, but please book. I mean, it's conceivable, by the way, as well. The maximum capacity of that room is 78 people. So as we got to 70 last year, it's conceivable it would even sell out. So if that encourages you to book it earlier, that would be really good for me as well. It stops me sweating and chasing, a bit like I did for the Hamfest coach trip. So there we are. That's our Christmas dinner, just a week before Christmas, Wednesday, the 18th of December. And while we're talking about dates for special events at the club, we've also got something which I know is always popular, and that is a tabletop sale. And we're doing that on Wednesday, the 13th of November. So put that date in your diary now. It's 3 weeks' time, and that will be between 7 and 9:30. It's free to attend, as the slide shows, and you can buy and sell, and it's free as long as you're a member of the club. By then, we'll be taking membership as well for next year. So you'll be able to join the club. If you're not already a member, you better join then and carry it over to 2025. Where the heck did 2024 go down?
Yeah, I don't know.
So there we are. Tabletop sale, Wednesday, the 13th of November. It's the first time I've announced that date. So we're getting our plans sorted out now in the run up to the end of the year. Now we've got time for some members news. And I've heard from Mike M7TTT. And it's all about UHF. I think we've got a picture here, so let's just show one of those pictures here. The idea of being truly portable has always appealed to me. This is Mike. Although I'm working on my HF kit, I do love my Baofeng UV5RH handset. But when a couple of club members tutted and said, you'll not get far on those squitty little things, 5 kilometres if you're lucky, or words to that effect, it was like a challenge to me. I'm still learning, so the idea of experimenting seems quite exciting. But why only do the easy stuff on HF with loads of help from the ionosphere? That's way too easy for me. My Baofeng's putting out a solid 9.9 watts on high power, so as long as I solder cleanly and try not to let little ohms escape the tubes, I should be getting out as well as my antenna. My first handheld DX was from the highest mountain in Norfolk. No, don't laugh, he says. It's 433 feet above sea level, and it's the Roman camp at Sheringham. Using the same radio and a 3-foot tactical whip, I got through to NR3GB 70 SEMS repeater some 36 miles away, and had a QSO with NARC's Martin M7HSF. On Sunday the 13th of October, I drove to Lowestoft and Ness Point, the most easterly point of the UK, but no official RSGB Ofcom map reference name. Using my newly modified 3-element Yagi Star beamer with military-grade coax, I managed a very clear QSO with NARC's Ian M7 DSX. This is a decent 22.9 miles. The little antenna was reaching above the cliffs and buildings which stand much higher by Lowestoft Lighthouse. It's way beyond my comprehension as to why 70 SEMS is treated almost like, dare I say it, CB. A quick meet and chat frequency. It's not. It's a ham band, and a good one, and obviously not just line of sight. I shall continue to test and experiment with 70 SEMS and maybe build up a small list of good spot, blind spot and types of antennas I've used. So far I'm loving it, possibly a tad more than the easier HF. I think that's controversial. Anyway, Mike, thank you very much for the piece. I'm always appealing for news for the programme, and you've certainly done us proud there with your words and pictures. Thank you. Now time for a quick piece of news as well from Bob, G6PWS. And he sent us this picture and says, guess what the oak tree is known as? It's fantastic, isn't it? It's a real character.
It's a bit like mermaids.
It is, isn't it? Anyway,
Legs.
To reveal where it is, it's in the grounds of Hatfield House, and is said that Elizabeth I played around and on it. There we go. That's pretty old then.
Yep.
Does look lovely, full of character. A friend of ours has got a tree like that a bit in their garden, haven't they, with just so much character. Lovely. So thank you very much for those pieces of news. Now, Tammy, over to you for Little People.
Yep, Little People. Now, I know you like a train.
Well, yeah, now you come to mention it. Oh,
The onion train.
Is it onion? Oh, I was going to say it was pasta.
No. Spring onion train.
Lovely. Oh, that is lovely, isn't it? Real railway track as well.
Yep.
It's from our friends at miniature-calendar.com. New picture every day, and Tammy picks one out for us. Thank you. It's a really always ingenious what they do and how they use everyday objects. But that is brilliant out of onions. Thank you very much, Tammy. So what have you been doing? We've had a couple of bits of news as you saw this week. Do let us know before we meet here again in 2 weeks' time. You can send them to the usual address at radio@dcpmicro.com. And as long as you get them to me by 3 o'clock on a Wednesday that we're broadcasting, then we'll be happy to include them in that night's programme.
Bob is just put a comment on. He said it's called the elephant oak.
Oh, is it? Oh, he didn't put that in, I think, in your email, Bob. Thank you very much. Elephant oak, yeah. That would make sense, wouldn't it? Good. We didn't
The big trunk. Oh, I see it now. I'm just going to put that back on the screen a sec. Yeah, it does.
It does, yes.
It's an elephant with the ear and the eye and the trunk.
I think there's a lot in there. It's one of those things you could sit down and look at it all day and see so much in it. Thank you. It's a lovely picture, Bob. Excellent. Thanks. So do keep in touch with us. Now, and also the card as well. I must mention our Norfolk Amateur Radio Club card, which of course we're happy to send to anybody who's going to cheer them up. So just drop me an email with their details, their address, and we'll be happy to post it anywhere in the world. They don't have to be amateurs, they don't have to be members of the club. Now let's get back to that competition that we set 2 weeks ago when we asked you, what on earth is this? This is going to sort of, I can't say men's from the boys, I have to say the girls from the women, I suppose now as well, to be politically correct. So what is that? Any idea? Anybody else gone here? I've got some answers here.
No, I don't think we have.
Okay, let's kick it off then with Stuart M0JKB, who says, I think this could be a comb binder. Zena used to use one at work, and we spent many a happy hour putting training materials together for their courses.
Paul G3VBT, I think is a binder for manuals, etc.
Bob GSTU, a wild guess, part of a jacket zip.
Pete G4RAV, your picture this week is the flexible ring binding for pre-purchase papers, which as a result of application will then hold the said papers together in a booklet form. And
Julian M0NUX, nice to hear from you, Julian. I think this is a binding comb used with a manually operated machine to punch holes along the binding edge and then thread the comb into it. It's not often we say this, is it?
No.
But the answer is none of those.
Dun, dun, dun. That is what the technical term was that was written in the email, which is why I put it on there.
Yes, and it was Nev M0NFY. I think he's tricked everybody here. I'm not sure I'd have known what that was unless, put it in context, I might have thought, oh yeah, I've seen one of those. But it mixes glue, basically. Araldite, that type of glue, mixes it up in a tube. And I guess it's not very even, so it couldn't have been the comb binder, but I get where everybody was coming from. It's very rare that somebody wins. We get quite a few guesses, but they weren't right. So well done to all of you. Oh, yep, M7LLS. Mark says, is it one of those A4 binder things? No, Mark, sorry. No, you were wrong. Everybody was wrong this week, so well done to Nev. Extra points for you for that. Thanks very much for sending him. So let's now have a look at our new competition picture, which we'll reveal in 2 weeks when we ask you to tell us, what on earth is this?
I knew what this was.
You would.
For the record.
Can we say who gave it? Would that help or not?
No, don't say
I think
who
it's
gave
quite
it.
funny, actually.
No, don't say
I wouldn't
who
have
gave
expected it from this person.
No, don't say who gave it.
All right, okay.
You have to
Do what
wait.
the boss says.
You have to come back in 2 weeks.
All right, okay, I will. There we are. What on earth is that? Do you know? Can you take a guess of what it is, what it's used for? Drop us a line to radio@dcpmicro.com by 3 o'clock on Wednesday in 2 weeks' time, and we'll reveal all that evening as well. Just time to tell you what's happening on at the club before we meet tonight's guest. And on Sunday at 7 o'clock, the GB2RS News on GB3MB. On Monday, it's the Monday Night Net on GB3MB at 7:30 also. And next Wednesday, October the 30th, we're back to meeting at CNS School for an informal social meeting from 7 till 9:30, including that show and share table to offer free things you no longer need and for others to fill a hole. If you've got things that you want to sell, then obviously wait a couple of weeks after that, because that will be our tabletop sale. We can also be free things as well, I guess. And said, please keep in touch with your stories and everything like that. So, tonight, on to tonight's main event, and we're very pleased to have with us a guest who's not in this country, is in Cyprus actually at the moment, but as you'll tell when we meet him, he maybe wasn't born there originally. But it's lovely to welcome Bob Henderson, 5B4AGN. Hello, Bob.
Good evening.
Good
evening to everyone.
Yeah, thank you very much indeed for joining us tonight. We've got to I wouldn't be a Brit, would I, if I didn't ask you about the weather first. So what's the weather like there in Cyprus? Are you going to make us jealous?
Well, we're finding it a little bit cool now. It's we've been having over the summer up to about 38 degrees, but it's rather chilly now at around 22.
Chilly at 22. Oh, it's not like that here, you'll remember. Can I just ask you before, we're going to obviously let you do your presentation, but how long have you been living in Cyprus? You were obviously from the UK, from somewhere originally?
That's right, from the UK. We last lived in North Yorkshire, and we came to Cyprus in 2000. So we've been here for 24 years, although we had visited Cyprus many times prior to actually coming here to live.
And what's radio like there? Is it a popular hobby, amateur radio?
Reasonably so, but you know, the population here is relatively small. We're talking about 1 million. So really the population of the island is rather like the population of a large city in the UK.
Yeah.
So given the size, yeah, I mean, we have quite a few active amateurs. A lot of XG amateurs, actually, as well as locals. So it's quite busy amateur radio-wise, I guess. Good.
Well, we're looking forward to your talk tonight on filters, LC filters for multi-transmitter installations. And I'm just a message for everybody at home, of course. If you have any questions or observations or any comments for Bob, then ask them at any time on BATC or on Facebook Live, and we'll read them to Bob at the end. But now I'm going to hand over to you, Bob, for your presentation.
Okay, many thanks, David. Again, good evening, everyone. Hopefully you can see me, or at least see my presentation slides. I don't have the pleasure of actually seeing you, but I'll trust that you're there. Roger asked me to put together a presentation for you on LC filters, and these are most frequently used where we have multi-transmitter installations. Of course, they're used in many other applications as well, and the radios that we operate are full of these things, but it's really looking at the possibility of using additional filters for specific purposes outside of the radio itself. First, a little bit about me. Yeah, I'm a Brit, and my UK call sign is G3ZEM. I was licensed a bit over 54 years ago with that call sign. So operated radio from the UK for a good number of years before coming here 24 years ago. I've really engaged in many aspects of the hobby. I'm a contester, though less so these days, but I have been very active as a contester over the years. Likewise, a very active DXer. I've done quite a bit of de-expeditioning with other people, but also on my own single-man de-expeditions to a number of places, as you can see, to East Timor, Togo, Ghana, Nauru, the Marianas, Guam, and others, as you can see on the slide. I'm mostly a CW guy, so I'm a CW rag chewer. That's not to say I don't operate SSB, I do, but relatively little by comparison. I also operate RTTY and data modes these days, but my love in amateur radio is CW. Then, in addition, of course, I'm a keen constructor and experimenter. So I've covered quite a lot of the ground. These days, I'm active all bands from 160 to 6. Not too much activity in these parts above those frequencies. There are one or two campaigners that do some on 4 meters and 2 meters, but I haven't really ventured up there whilst I've been in Cyprus. Off you go, Archie. Can you get Archie, Karen?
Yeah. Archie, come on. Archie.
Sorry about that. Interruption from the hound. Okay, so if I can talk firstly a little bit about filter basics. This is strictly about LC filters, inductors and capacitors combined to produce tuned circuits, which are together to make filters. The basic components, capacitor, inductor. The capacitor has a reactance, which we call XC, and a capacitor, any capacitor, has its highest reactance, which is like reactance, I'm sure you all know, but reactance is effectively alternating current resistance. And this is at its maximum at low frequencies and reduces as the frequency increases. The inductor is the opposite. The inductor has a reactance XL, which is at a minimum at low frequency and increases as the frequency increases. Resonance occurs in an LC circuit when the inductive reactance and the capacitive reactance are equal. And this is a very important characteristic, and this forms the fundamental building block of LC filters. So if we look at quickly at resonant circuits, parallel resonant circuit on the left, where the inductive and capacitive reactance are the same, at resonance, the impedance across the circuit is very high. Whereas in a series circuit, the same capacitance and inductance would provide for a very low impedance at the resonant frequency. So these are the two fundamental circuits which are put together to provide all kinds of different LC filter circuits. A low-pass filter. Everyone who has a radio, a transmitter, will have low-pass filtering on the output of the transmitter, essential to prevent harmonics from being radiated. When you want to operate on whatever band, let's say 20 meters, when you're operating on 20 meters, what you don't want is to be heard on 10 meters at the same time. So you need to have filters in the output, low-pass filters, which will suppress the harmonics. So that's the primary use, I guess, of a low-pass arrangement filter. A high-pass filter, the logical opposite of what went before. This allows high frequencies to pass through, whilst low frequencies are attenuated. So the low frequencies, the inductive reactances present very little barrier to low frequencies, but present a high barrier to high frequencies, so they don't come and go to ground. The capacitor prevents a barrier to low frequencies, so they don't pass through to the output, whereas the high frequencies pass through. And this is the kind of response that you would expect, where this is the pass band, and this is the stop band of the filter. A typical use for this, or an example of use, I guess, would be if you had a transceiver and you were a keen 160-meter operator, but were unfortunate enough to live next door to a medium wave broadcasting station, you might need a filter like this, a filter that would have a sharp cutoff below 160 meters and prevent the high power medium wave station from causing interference to your receiver. That's an example. There are many examples, but that's one that I thought of that you could maybe relate to. The next type of filter is a band stop filter. This is the kind of filter that stops just a specific frequency or small band of frequencies, allowing all frequencies above and below that stop band to pass freely. And an example I could give for this is if as an example, you had a transceiver with a 10.7 megahertz IF, and you wanted to operate on 30 meters. What you wouldn't want happening is for the local oscillator for your 10.7 megahertz IF to appear in the output. So you may use a very narrow stop band filter or notch filter to filter out that carrier from the conversion oscillator that you don't want to appear at the output. And finally, the bandpass filter. And this is the filter that we'll be focusing on further this evening. This is where you want a band of frequencies to pass through, but you want frequencies outside of that band to be attenuated. And this acts both on transmission and on reception. So for example, you may want a bandpass filter that allows the 20-meter band to pass in both directions, but keeps out RF from 15 meters, 40 meters, and everything else around about. So here is where, for example, would we use these things? We would use them in multiple stations, where multiple stations are in close proximity. And for example, in contesting, a multi-multi or a multi-single contesting station will have two or more stations acting at the same time, or one will be transmitting while another is receiving, and so on. What we want is for them to be able to operate without interfering with each other. This is a similar requirement for de-expeditions, where we have big de-expeditions with multiple stations on multiple bands. They would be very much less successful if all they did when they fired up was interfere with each other. And equally for exhibition stations, if we have an exhibition station with more than one transceiver, then this kind of filtering, bandpass filtering, would be beneficial. We wanted this kind of filtering to do a number of jobs: to protect the receivers from crossband interference, and yet worse, from potential damage. You know, if we're in a situation here with a number of stations next to each other using antennas in close proximity, there is the possibility of very significant levels of RF being passed from one transmitter to the receive antenna on another. And a particular example of that was here. As part of my contest station, I had a C31XR antenna, which was a force 12 antenna. And this antenna was 3 elements on 20 meters, 4 elements on 15 meters, and 7 elements on 10 meters, all on a single boom. and the distance between the driven elements, so between the 20 and 15 and the 15 and 10, were in each case less than 30 centimeters. So you can imagine these driven elements were in the same plane, they were parallel to each other and spaced only by about a foot. So the amount of RF, if running a kilowatt on 20 meters, 30 centimeters away from your 15-meter antenna, a lot of RF is picked up by the 15-meter antenna and likewise the 10-meter antenna. Enough RF to completely fry the transceivers that are on receive. So the purpose of the filtering is to prevent that happening and to prevent audible interference on receive too. So it's to heavily attenuate out-of-band signals on receive, to reduce the radiation of transmitter harmonics, and also to attenuate broadband PA noise. All PAs, all output transistors, for example, will generate some level of broadband noise, not just the signal that you intend to transmit, but a broadband noise, underlying noise. Some transceivers are much worse than others, but of course, this is most unwelcome. It is broadband, so you don't want to be increasing the noise floor in each of the associated receivers. So the purpose of the narrowband filtering is to prevent that. If I can move on now to design of filters, because hopefully some of you in the audience may have interest in designing your own filters, whether they be low pass, band pass, high pass, stop band, all of these possibilities. And I recommend to you a program called LC. You get it, it's sort of LC, hence LC. This program was written by Jim Ton, W4ENE, who's a good friend of mine. And it is available, downloadable from the web. If you look in Google for LC download, it will come up with a link to Ton software, and you can have a student edition free of charge, and that will allow you to do many things. It is well worth having. At this point, it had been my hope to be able to switch to LC, which I have running here, and show you how easy it is to design a filter using the program. Unfortunately, I have not been able to do that because LC, the rendering in an LC screen is not rescalable. It exists on a full screen and cannot be resized. You can resize the window, but it blocks out part of what's on the screen. So the elements themselves aren't capable of resizing. So that renders it incompatible with Zoom. So what I've had to do is to take some screenshots as a second best, if you like, and I will talk you through that. So this is the design screen of LC, and I'll use the mouse to point a few things out. What I've done here is to say, well, let's look at a shunt input bandpass filter. Shunt input simply means that the input to the filter is a parallel tuned circuit across the input, from the input to ground. That's a shunt input. I've chosen a Chebyshev topology or the Chebyshev family, as that is frequently used in bandpass filters. And I've set here a number of characteristics which are required in order for the program to design the filter. So just for the purpose of this exercise, I've set the bandwidth of the filter to be 1.5 megahertz. I've set it with a center frequency of 14 megahertz. I've opted for a third order filter. And what that means is there are effectively 3 tuned circuits in the filter. That's a third order filter. And I set the input termination to be 50 ohms, characteristic impedance of the coax that we use, the output of our transceiver and so on, where it will be intended to live. And I've requested a very, very low passband ripple, 0.01 of a dB. With this kind of filter, which is going to be used for passing significant amounts of RF just on the output of your transceiver, which may be 100 watts or perhaps a 200 watt transceiver, you can't afford to lose too much in the filter because in doing so you could generate heat and so on, which may damage filter components. So you want low passband ripple and low insertion loss. Okay, so if I move on to the next slide, this will show you the filter that these characteristics yield. This is the plot. So up here, we're about 1.5 megahertz wide, very low loss. Typically, you would expect it to have a loss of around about 0.4 dB. And you can see that down here at where roughly 7 megahertz lies, so the next lower contest band, we've got attenuation of around 50 decibels. Up here on 10 meters, we have an equivalent, approximately 50 decibels attenuation. You notice looking at it that the roll off on the high side is more gentle than it is on the low side. This is because the difference is 1 octave, and 1 octave on the low side is half the frequency. So half of 14 megahertz is 7 megahertz, a 7 megahertz gap. But 1 octave on the high side is double the frequency. So 14 to 28 is 14 megahertz. Not a big problem, except for the fact that in the middle we have 15 meters sat here. And what this shows is that in this particular configuration, 15 meters would have an attenuation of around 35 dBs, which actually is pretty good and is probably adequate for, for the purpose. But there are configurations that can be used which could increase that attenuation. You could either increase the number of poles, make it a 4th order or 5th order filter. Of course, that increases the component count. Or you could perhaps use a different topology of or configuration of the filter. If I then go from here to the schematic. So to design the filter, LC is now telling you what the values are. So it tells you the input circuit, the capacitance and the inductance, the series circuit, again, capacitance and inductance, and the output. Input and output are the same, you will note. The filter is symmetrical. One thing I'll mention here for anybody who might be contemplating following this path and maybe making some bandpass filters or others, is that actually when you look at the values in the middle, 5.1475 microhenries and 25.1 picofarads, these are reasonable values that you can achieve and achieve at high Q, which is high quality factor. as far as the input and output circuits are concerned, this is not the case. 96.7 nanohenries is a very small inductance for use at HF, and it would be difficult to use these and get high Q. There is a way around this, and the way around it would be to use trifilar or quadrifilar inductors, where effectively with a quadrifilar inductor, for example, you will have 4 windings, and these will be in series. On one of the windings, that will go between the input here and ground. The other 3 windings will add to the top of it, and instead of the capacitor being this resonating capacitor being directly across this part of the coil, it would actually be up here across the 4 coils which are in series. And what that would do is change the arrangement so that the capacitance became much smaller whilst the inductance increased. And in doing so, that would give you a much higher Q, so a much better performance of the input and output circuitry. I could have demonstrated that if I'd been able to get the application to run. Sadly, not quite so easy otherwise, but hopefully my explanation serves. So looking at all of that, you say, well, what about all of this nonsense, and why not just simply buy the filters that you need? Well, this goes back in time to, for me, to 2008. In 2008, we'd spent a number of years building up a multi-2 contest station here. And we had problems. We had every year, we had failures of the bandpass filters. We had capacitors that blew. We had relays in which the contacts welded together, not through transmit power. These relays were perfectly fine. Once the contacts were closed and you transmitted through them, no problem. The problem occurred when the station that was on receive changed bands whilst the other station was transmitting. And this provided cross-coupled RF from the antenna, which was reflected back to the bandpass filters. The filters themselves would block them from getting to the receiver in the other radio. But on their way, they would manage to weld close the contacts of some of these small relays in the filters that we'd been using. And the kind of filters we used were 6-band units. And if you had a problem where a capacitor blew or a relay lost its contacts, then the whole filter for 6 bands had to be removed for repair. You couldn't just remove the failing component. It was impossible to do. So all of this, we suffered this for 3 years with multiple failures, and we couldn't find any commercial filters that were any better than those we'd been using. So I finally decided we'd better do it ourselves. At the time, these were the commercial units that were available. There was a Dune Star 600. These are on the right-hand side. These are the small filter select relays, which occasionally would, the contacts would weld. They also use leaded ceramic capacitors, which were fine. As long as everything worked fine, they were fine. An occasional accident that would cause a short to the output while there was RF on the input would cause these capacitors to burn out. Equally with the ICE 419 filter, which was the only alternative available at the time, the relays were okay, much heftier relays. We never managed to weld those together, but a lot of the capacitors had similar problems. So we moved to a situation where we had to do our own. And so we wrote down what it was we thought needed to be done. We wanted these things to be close to bomb-proof, or as close to bomb-proof as we could produce, i.e. we'd had enough of failures. We didn't want to have any more giving up the ghost in the middle of a big contest. So we set out to beef up the failing items. We went for custom mica capacitors that were made for us by a British company, now Charcroft Components, although it was Tab Mica back in those days. And these are mica capacitors made with mica that is guaranteed ferrous-free. One of the problems with the little red mica capacitors is they can have a significant iron content that makes them prone to heating up and helps them disintegrate under unfriendly conditions. So these capacitors, expensive though they were very, very much better. The next step was to put higher spec filter select relays in there, to develop the filter with a mother and daughter board approach. So the motherboard had basic stuff on it. It had the coaxial feeds and all the rest of it. Each band filter was on a daughter board, which was plug-in and could be removed. So in the case of a failure during a contest, you could just remove the filter for the band where the failure had occurred, and the other 5 bands would continue to be usable whilst the filter was repaired. We made them with plug compatibility for JuneStar because most people were using JuneStar filters at the time, as were we. I put in an integrated manual select switch and LEDs to indicate which band was selected, and an integrated band decoder and antenna relay driver. So the unit could be driven directly using Yaesu and Elecraft band data, and it would provide buffered outputs that would drive the antenna select relays directly. So changing bands was automatic. As soon as you change band on the transceiver, the bandpass filter changed, the antenna switch changed, and so on. And this is a photograph of one of those filters. There have been a number of group buys for this over the years that I've managed. Alas, no more, I have to say, so they're no longer available. But more than 1,000, I was going to say 1,000 people, it's not 1,000 people, more than 1,000 kits for the manufacture of or assembly of these filters are in existence. How many have actually been built and how many still remain in kit form, I don't know. But they ended up shipped all around the world because once word got out, we started off, I intended to make the filters for ourselves, just for P3F, but it struck me that getting printed circuit boards wouldn't be economic just for us. So I put a note on the UK contest reflector, and within a day, we had 50 people who wanted 50 of these things. So the first batch was a batch of 50. They went off and people built their own and put them into use and so on. And I thought that would be the end of it, but it wasn't, because other people saw them and wanted them, and I ended up involved in numerous rounds of group buy for the components and all the rest of it. So a lot of these are out there. They have been very successful. They largely met the design criteria, with 15 and 10 meters, mostly 15 meters, occasionally suffering hardship. And the problem was that even with these vastly improved capacitors, the series capacitor could fail. The problem being that the plate area of these capacitors reduces as the capacitance reduces. So on 160 meters, the series capacitor is 250 picofarads. That's got quite a big plate area, and the capacitors are pretty robust. By the time you get to 15 meters, the capacitance for the series capacitor is 14 picofarads, much smaller plate area, and therefore much more prone to damage with high current. And so things like an occasional short circuit to the output would cause that series capacitor to blow. It never happened to us, I have to say, but it did happen to other people. And so the only modification that really happened through the life of these things is the move to coaxial capacitors, here for 15 meters and here for 10 meters. And these things really are bomb-proof once you replace these with coaxial capacitors. You can short the output, open circuit the output, and there is not a chance that those are going to blow. The alternative to the multi-band units was a series of single band filters. These were made largely for de-expedition use or for multi-multi contesting, where you know, in multi-multi contesting you have a station per band, so it would only need a filter for that band. And likewise for de-expeditioning with multiple stations, they don't all need to be able to move from band to band just by pressing the button. They could have specific filters dedicated to the band in use. And a useful facility with that, with just one set of filters, you can make a very simple rule for people that if you don't have the band filter for the band you want to operate, you can't operate it. So you don't get any conflicts with whoever, you know, two people trying to be on the same band. Only one filter, you've either got the filter or you haven't. So it was a good arrangement for discipline in management of de-expedition stations. So for me, aligning filters, I used a very accurate VNA. This was a home assembled VNA that was designed by another friend of mine, Paul Kisiak, N2PK. And actually this VNA is far more capable than many of the highly priced commercial VNAs. It has up to 120 dB of dynamic range, which makes it useful for many obscure applications, and equally makes it way over the top in terms of its capability for this kind of work. A VNA with a dynamic range of 60 dBs, half of what the N2PK VNA has, would be perfectly adequate for this kind of LC filter alignment. And I used the N2PK with software developed by G8KBB called MyVNA, which is extraordinarily good software, and together with the N2PK VNA gives tremendous flexibility, accuracy, and so on. If anyone is interested in developing their own filters or building their own filters and wanting to align them, these days there are a lot of offerings available by way of vector network analyzers, which are relatively low cost. You can now buy a thing called a nano VNA or a tiny VNA at a cost anywhere between about 50 and 150 euros, or a bit less in pounds. So it's something that is relatively easy to put together a test setup that will allow these things to be relatively easily aligned. This is just an example of an output. This is what was on the screen that you couldn't see in the previous slide. So this happens to have been a 160 meter filter, which is roughly aligned. It shows here that the two markers at the top are markers 1.8 nominally and 2 megahertz. And over here, I don't know whether you can read these, but the top two indicate, I think, 1.78 megahertz and 1.98 megahertz, where the insertion loss is somewhere less than 0.3 of a dB. So perfectly good for transmit kind of filter. This is the passband and the passband roll-off. You can see over here at 80 meters, the attenuation is around 50 dBs. Lost my arrow, but that's it there. This second graph here is what is known as return loss. And you can see from here, this is the scale for return loss between 0 and 40 dBs. So the return loss it's peaked at 30 plus dBs at either end of the band. It's a bit less in the somewhere in the middle, but still 20 something dBs. To convert that, just to give what is perhaps a more familiar perspective, 30 dBs return loss is roughly, I believe, 1.05 or something like that to 1 SWR, and 20 dBs will be about 1.14, I think. That sort of order, 1.14 to 1. So perfectly reasonable. Anything over 20 dBs return loss is perfectly adequate to ensure that losses in the filter are within manageability. So if your station is just a transceiver, bandpass filters on the output of the transceiver or between the transceiver and the antenna will be fine, as long as your antenna on each band presents 50 ohms nominally. The bandpass filters will block on one out-of-band RF from other stations next to you. It will also block harmonics being output from the transceiver and prevent them causing interference to the other stations on receive. So if this transceiver is on 80 meters and your neighbor is on 40 meters, then the bandpass filter will stop your second harmonic that's in 40 meters from being too strong. That's a great plan and works very well. But of course, as soon as an amplifier is added, a high power amplifier, then it doesn't matter how well you suppress the harmonics coming out of the transceiver. The amplifier will create its own. So in this arrangement, the amplifier needs to be followed by its own high power bandpass filters or coaxial stub filters, or perhaps both. I have operated this last few years from E2A, which is in Thailand, and there we have multiple installations together, very closely together, multiple towers, a lot of antennas very close together. In that setup, we have bandpass filters between the transceivers and the amplifier. We have bandpass filters on the output of the antenna switches. And then we also have stub filters. So belt braces and a corset, I think, is what we've gone for there to try and make sure that there is no interstation interference. So I thought at this point I would just talk a little bit about coaxial stubs. A good old sine wave. So if we have one wavelength of coax, then you would see a complete wave over that length. You can also see that if the voltage at zero degrees is 0, at 90 degrees here, the voltage is at maximum. This is important, and in producing coaxial stubs to prevent interference, we use either quarter wave stubs or half wave stubs. Now, with a half wave, if at 0 degrees the voltage is 0, then when you move away half a wavelength, or 180 degrees, it is equally 0. If it is at a peak, then half a wavelength away from that, it is still at a peak, albeit of the opposite polarity in this diagram. So with that basically says that over a half wavelength of coax, the condition at the far end of the coax will be reflected to the condition at the beginning. So with a half wavelength of coax, if the far end is open circuit, the near end will be high impedance. If the far end is a short circuit, the near end will be low impedance. Now, with a quarter wavelength of coax, as opposed to a half wavelength, you get the opposite happening, in that if the far end is open circuit, it will be a high voltage. The near end will be low impedance, low voltage. If the far end is a short circuit, so it's got no voltage, then the near end is going to be high impedance and high voltage. And so we use a mixture of quarter wave, half wave stubs, shorted or open circuit, dependent upon just what it is we want to achieve. Now, LC will also allow us to model this. One thing that I should mention is that when you get to cutting coax to do these things, there is an important characteristic to be taken into account, and that is the velocity factor of the coax. If you want a quarter wave at 20 meters, you would think that's 5 meters. But the velocity factor of the coax is likely to be about 0.8. So that would make it a 4-meter length of coax rather than 5 meters for a quarter wave length. So you must take into account the velocity factor, but when you're cutting coax, by all means, you take into account the velocity factor, but then you add a bit so that you can trim. There's nothing worse than trying to do it exactly and find that you've cut the thing too short, because velocity factor in coax is nominal. Over 100 meters length of coax, you might find it's 0.8, but over a 4-meter length of that same coax, you might find that it's varied a little bit. So you will always need to give yourself the wiggle room, if you like. This is going back into LC, but in this slide, we're not using discrete inductors and capacitors. We're using pieces of coax as stubs. And what we have here, so this is an 80 meter set of stubs, which will pass 80 meters. So it's an 80 meter band pass set. So to achieve that, we have a 90-degree or a quarter wavelength at the 80 meter frequency you want, in this case 3.53 megahertz, shorted. So what that does is it's shorted at the far end of the quarter wave. It's going to be high impedance at the near end, so it's not going to be shorting out your transmit signal. Equally, this one on the other end is the same. We've then got a link between the two. And let me explain what this is about. A single stub, which would just be this item here, number 1, will give around 30 dBs of attenuation at the intended frequency. In this case, it would give around 30 dBs of attenuation on the second harmonic, which is 7.06 megahertz, 7.06. But there is a problem with this. This 30 dBs is, it's a bit like a magic 30 dBs that it's very difficult to put your finger on. And the reason for that is, I'll try and explain. Your power coming out of your transmitter on 80 meters, going to an antenna which is well matched, many meters away, I don't know, maybe 50 meters away, 50 meters of coax away or whatever. The power coming out, if that antenna provides a good 50 ohm match, that power is a traveling wave. It travels all the way from the transmitter to the antenna where it is radiated, all very successfully. However, along with that wanted signal coming out of your transmitter, you also will have harmonics. So you will have signal coming out on 40 meters, another coming out on 20 meters, another coming out on 15 meters, and another coming out on 10 meters, all from your 80 meter signal. And all of those, well, 15 meters may be slightly different. You may get a semi-decent match at 15 meters, but at 40 and at 20 and at 10 meters, the impedance will be much, much different. And so that will set up standing waves at the harmonic frequencies over the coax. When you've got a single stub that you want to use to trap those harmonics, the question is, where do you put it in that length of coax that comes from the output of the transmitter to the antenna? Where you want to put it is where the harmonics are at their voltage maximum. But where is that? It's almost impossible to determine. It is determined by the load at the far end of which is the antenna. The antenna that doesn't provide a good match at the harmonic frequencies will set up the standing waves back on the coax. identifying exactly where that high voltage is not an easy thing. So this is why, instead of having a single stub, we use double stubs. A lot of people have tried with single stubs. Some people have found them hugely successful. 30 dBs attenuation, great. Somebody else has tried it and found that they've only got about 5 to 10 dBs. And the reason is that they're not managing to hit the voltage peak. And so it's wrongly positioned. However, where you put that first stub forces at the harmonic frequency are short to the harmonic. The quarter wave you see here on 80 meters is, of course, a half wave on 40 meters. And so the half wave on 40 meters, shorted, produces an effective short circuit across the coax for 40 meters. This now gives us a known position. We know exactly where the minimum voltage is. And so we then join, using the length of transmission line, a second stub, and we know that that second stub can be ideally located along the transmission line to give good attenuation. If what we need to do is focus upon attenuating the second harmonic and the second harmonic alone, it becomes quite easy. We use another length of coax, in this case 45 degrees, a quarter wave length of coax, to connect one stub to the other. And the quarter wavelength at the operating frequency is the ideal length to give maximum attenuation of the second harmonic. But of course, this is an 80 meter bandpass arrangement. And so we're not just interested in squashing the second harmonic at 40 meters. We want to squash the harmonic at 20, the harmonic at 15, and the harmonic at 10 meters as well. So there may be a better arrangement for doing that. If I go on to the next slide, this shows you, for the filter arrangement I've just shown you on the previous slide, here we have between 3 megahertz and something over 5 megahertz, very little attenuation. So 80 meters will go straight through, which is exactly what we want. We have here about 107 dBs of attenuation of 40 meters. So that's really wrestling down the second harmonic. Third harmonic, we've got 80 plus dBs of attenuation on 20 meters. On 15 meters, 100 dBs. There's a bit of a problem here on 10. It's only 40 something dBs. Now, the other thing I should mention is your actual stubs will not give as much attenuation as indicated here. These are essentially lossless, whereas you're in the real world and you will get wider. The dip will be a bit wider in each case, but not as deep. So by the time you get to 10 meters, you may only be getting 30 something dBs of attenuation. So in a case like this, for 80 meters, if incidentally that was a 20 meter filter we've been building, then that quarter wave coupling link would be exactly right, because if it was a 20 meter filter, we're only interested in the second harmonic, which is 10 meters. So maximum attenuation of the second harmonic, quarter wavelength of 90 degrees worth of connecting cable. But I tried it here with what effectively is 1/16 of a wavelength, 11.25 degrees. And the next slide will show what reducing that coupling link does. So all of a sudden, we've sacrificed a bit of second harmonic attenuation. We're now at about 98 dBs instead of 107. Third harmonic is still very good, better than minus 120. Third harmonic is unchanged, 100 dBs. But on 10 meters, rather than 30-something dBs, we've now got about 81. So for an 80-meter bandpass stub arrangement, that shorter link between the two stubs is a better arrangement. You could probably play around and maybe find something that is even better for your own needs. But that shows that the normal default coupling between stubs of 90 degrees is not necessarily the right way to go if you've got multiple harmonics to worry about. That brings me to the final slide, where that's just a summary of what I've shown there. The 45-degree link cable gives these figures: minus 107, minus 85, minus 100, and minus 47. I thought it was 30-something, 47. But going to 12.5 degrees, we sacrifice 10 dBs at 40 meters. If we can afford to do that, it wins us 35 dBs at 20 and 34 dBs at 10 meters, with no effect one way or another at 15. That brings me to the end of my presentation. So if there are any questions, I'll do my best to answer them.
Thank you very much, Bob. A lot to think about, a lot to take in there. But as Bob has just said, we haven't got any questions or comments yet, but I don't see that as bad. It just means there's a lot of people have been paying a lot of attention. But if you have a question at home now or a comment to make to Bob, maybe you've experienced this, and your filter, when you mentioned the TX BPF, I've certainly seen some of those about, and I think it might be the same as we have here at Norfolk Amateur Radio Club. Actually, we've used it for contests, Bob. But
Quite possibly.
I'm not sure, but if you've sold 1,000 of them, then you're not going to remember everybody who's bought them over the years. So do let us know your questions and comments right now, either on BATC or Facebook, and we'll relay them to Bob. Now, Bob, as we talked to technical rehearsal a few days ago, as you asked me what the sort of range of people we had in our club would be watching this, and they are going to be everybody from real beginners who've just got their foundation, right up to experienced old timers. Are the things that you've taught us tonight, do you feel they're relevant to everybody, whatever you're running, or are they something really for performance stations like contest stations?
Well, I mean, it depends. They are potentially useful to everybody depending upon what they are doing. For example, you may need a high-pass filter if you've got somebody just operating from home, but they are getting interference from broadcast stations if they're operating 160 meters, for example. Then a high-pass filter could be used to sort that problem out. But in fairness, you know, these filters that I have described are mostly of interest if you have multiple stations together. So for contesting, if you've got you're doing a multi-single or multi-two or multi-multi kind of contest, these things are pretty well essential if you're not going to be just causing yourselves loads of trouble with one station interfering with another and so on. Likewise for the expeditions or demonstration stations for if you have an exhibition or whatever, anywhere where you have several stations together. Could also be applicable, of course, if your near neighbour's also a radio amateur, where you're close enough to cause each other interference. this kind of filter can help solve that problem. So I guess everybody, in certain circumstances.
Yes, thanks, Bob. That's very useful, actually. Someone has just commented, who's been watching, Chris, G0DWV, has just said Jim and Mike, Jim G3YLA and Mike G4DYC, who live very close to each other, if you don't already know that at home, really close, back gardens almost touch. They could benefit probably, as they're very clearly closely located, as Chris says. We've got one question from Chris as well. I'll come to that, Chris G0TZZ as well. I'll come to that in a moment, but can I just ask you now, you said your kits are no longer available. There are many people who, especially just starting out, they may find it a bit overwhelming to do these things from scratch. Are there any other kits or things available, or are there detailed plans, for example, how people can reproduce those things that you made over the years?
Detailed plans are certainly available. There is a group, Groups.io group. It's called TXBPF at groups.io, and anyone is welcome to sign up for that. That includes all of the documentation associated with these filters, and of course all of the communication that's gone between various people that have put them together in the past. I say that, for me, I mean, I've done group buys for these things numerous times, and this last time was actually last year, and I promised my wife that I would draw a line under it at that point, because it's just so demanding on time. It takes it's hard to describe just how much time is taken up doing these things, and life goes on, and I have other things I want to do, so I've had to draw a line under it. But anybody is welcome to use the documentation and so on.
No, I totally understand and respect that, Bob. As someone who's quite an active person in running this club and other things as well, I know what you mean. These things can run out of control, aren't they? My wife will look over now and nod. But I mean, have you ever, just as a final thing, and I'm not trying to persuade you, but have you thought of maybe licensing it to somebody else to make? It's just that, I mean, I've already got people here saying they'll buy 2 and things like that. I mean, I think that people would be out there to buy them. Have you thought of doing that?
Well, I did. I mean, and I'm open to that. The problem with it is these things were designed with home assembly in mind. So that means that they are not well tailored to automated assembly. Mm-hmm. That makes them less attractive to anyone who wanted to do it commercially, because of course it means there's a high manual content and therefore a high cost of assembly. It's exactly what you need if for somebody to do it at home. So, for example, the boards are laid out with oversized pads for the surface mount components, so that it is possible for somebody with just reasonable soldering skills to be able to assemble them. But it would be costly.
Yeah. I can understand that, Bob.
These days, there are commercial filters available. I mean, for multi-band auto-switched filters, there may be more than I'm aware of, but I am certainly aware of 2 companies, OM Power, that make high-powered amplifiers, also provide a 6-band bandpass filter, which I think they introduced, I don't know, maybe about 10 years ago. It's called the OM6BPF. And if you look at it, there'll be pictures on the web and so on. If you look at it, it looks remarkably similar to TXBPF. But they are available commercially. There is another company called Hamation, which is a US company, and they offer two different styles of multiband filters. One is a high performance one is a medium performance one. And so they are available if if you're interested in going that route, and rather than buying, which is exactly what we would have done had there been good filters available back in 2008. But what was available were not that good. I haven't actually had my hands on either of these companies' filters, but I believe that both are probably pretty well engineered.
Good, thank you very much. In fact, linked with that, I'll just quickly read Roger's comment. Roger G3LEI says, thanks, Bob. We had nothing like this in the early days of G4ANT, running 5 stations more or less simultaneously. How times change, he says. So,
Yes.
Gone to some questions now. Chris G0TZZ asks, where are stub filters connected in the antenna system?
Okay. They are placed in the feeder. You can put them, if you're going to use dual stubs, you can put them at a convenient place, because you're no longer hunting for this elusive voltage maximum for the harmonic that you want to squash, that's there as a standing wave on the line. By using dual stubs, you force a voltage minimum with the first stub, which means that then the second stub is exactly on the next voltage minimum. And that way you get high performance. So you place them where's convenient. In some cases, my stubs here are on the floor in the shack. So I have a corner bench with one of the, actually where I had my two radio single operator set up, with a big pile of coax underneath, and that's where I put them. In E2A out in Thailand, we have a stub cupboard on the outside wall. So inside the shack, we have the various bandpass filters after the transceiver, after the amplifier. Then out on the outside wall, we have stubs. So you can put the stubs pretty well where you want, where it's convenient.
Thank you. And just a supplementary to that, Chris says a couple of us run an M2 low power station, and we have horrendous problems with harmonics. We have filters on both stations covering all 6 bands, and have further filters after the triplexer to cover 10, 15 and 20 meters before the tribander. What else can we do to stop harmonics? Any advice?
Sorry, so you've got...
So I'll read it again.
This is 100 watt stations?
I don't know that.
Okay.
Maybe you can tell us, Chris. So I would guess so. Low power station. So I wouldn't think he means QRP, but he's probably talking about 100 watts, I guess. So a couple of us run an M2 low power station, and we have horrendous problems with, sorry, it's just disappeared off the screen. With harmonics, we have filters on both stations covering all 6 bands, and have further filters after the triplexer to cover 10, 15 and 20 meters before the tribander. What else can we do to stop harmonics? And Chris has also just said, yes, 100 watts.
Okay. Right, well, presumably the filters that are after the triplexer are switched. I'm trying to figure out how you actually do that.
Well, Chris, if you can...
Because if you've got a triplexer, then you have a single feed line from a tribander antenna. If you put bandpass filters in there before, between the antenna and the triplexer, I don't quite understand how that's going to work, because if you have if you have all 3 filters in parallel, then you might as well have no filters at all at that point, because it's all on a single coax. I don't understand.
He has just come back, Bob, and said this. Yes, is before the triplexer. So you don't think that will work?
No, before the triplexer is fine. So
Okay.
between the rigs and the triplexer, bandpass filters there make perfect sense. But the other side of the triplexer that goes to the antenna, you can't really add in additional filters. That's just got to be a direct connection between the triplexer output and the antenna.
Okay, I'm just going to explain a term just for our beginners. You know, we know we have a lot of newcomers to the hobby watching this as well. And a triplexer is something which combines, which you can buy them commercially. And if you've got, sometimes you have a transceiver with 2 or 3 different outputs for different frequencies, but maybe if you've got one multiband antenna, it kind of combines them all in one box, doesn't it? Is that a fair summary?
Yes, it does. I mean, I actually built some triplexers for guys who were entering WRTC. For a number of different country operations in different WRTCs, and they used TX-BPF, so one on each of the 2 stations, with the output of the TX-BPF going into the triplexer, and the triplexer then going out to the antenna, and that worked very well. One thing that I will mention is that if you have good bandpass filters, and despite the fact that you have good bandpass filters with good attenuation, you are still having problems with harmonics, then one of the things you need to consider is rusty nail effects elsewhere. Not only rusty nail effect, but a similar effect that you get from active devices plugged into the mains. So if I can just briefly describe what I'm talking about here, and a typical cause of this problem, and this is where you find you are hearing harmonics despite the fact you've got filters, but the harmonics that you're hearing tend to be heavily modulated with 50 or 100 hertz. And a likely cause is that somebody in the house, it may be your house or it may be in next door, has chargers plugged in. So telephone chargers, wall warts, these various power supplies and so on. And what happens is this: you radiate your power on 20 meters from your antenna, and part of it is picked up on the house wiring. The house wiring conveys the RF into a charger or whatever, and causes the charger to behave like the non-linear device that it is. You know, these are typically switch mode chargers and so on. And that in turn produces harmonics, which it then feeds back into the house wiring, which acts as an antenna radiating the harmonics. So you might, in certain cases, get rid of your harmonics very, very effectively. So coming out of your triplexer, going to the tri-band beam, you've really suppressed the harmonics, and they shouldn't be causing you any problem, or to the extent that you hear them, they're not worrisome. You know, they may be down at S7 and clean, just like another modest signal on the band. But instead of that, you get this horrible, zizzy, strong signal. And that can be caused by the problem that I've described. Another possibility is the rusty nail effect, where maybe you get harmonics generated by, if you have steel fencing where 2 pieces of steel which have corroded over the passage of time, work together to create a diode. The steel fencing acts as an antenna. It picks up some of the RF that you are transmitting, and the diode effect of the two pieces of corroded metal generate harmonics, which you then hear. So what you've got to do is you've got to find a way of measuring your harmonic suppression. You need to measure the harmonics coming out of your transceiver, for which, I don't know, you probably need access to a spectrum analyzer to look at this properly, and then to look at the similar output coming from your bandpass filters and through the triplexer. So to make an assessment of what is there and what sort of level you should be seeing in your companion station. And okay, if the harmonics are high, it means that your bandpass filters don't have adequate performance. If what's coming out is adequately suppressed, it means that you are subject to one of these external influences. Something non-linear is picking up your primary RF, generating harmonics from it, which you then manage to listen to.
Okay, Bob, thanks for the advice. I'm not, it's a bit late to tell you this now, but Chris has come back and said these are actually field stations in the middle of a field with nothing and no metallic fences and things around. So maybe that's not the problem in his case, but I guess at least having you say that it's valid to put them in line with before the triplexer is quite valid. So
I mean, it's essential that you have these filters before the triplexer, unless the triplexer inherently has
the filters built in. Yeah. Okay, thank you for that. I think that's all our questions now, and just lots of people saying thank you very much, very useful. And while you're there, I'm going to put up a caption now with the software that you mentioned, because that is really useful. So this is the software, the company LC software. That's what you need to do at home. Have a look at tonsoftware.com.
TONNE.
Yeah, that we've got it up and we've double checked it. So it's on the screen now for everybody at home. Have a look at that lovely free software that Bob's friend has written. 89 years young, you said to me today. He is. So I don't think we really could have expected him to modify his software to work with Zoom for us tonight, but it's really good to have things like that, though, are really useful tools, aren't they? Lots of people saying thanks. I said Dick G3WRJ says very informative and nice to see practical examples that work in high interference situations. Thanks very much for the talk. And that goes from us as well and from everybody else. Bob, thank you very much for joining us tonight. I know it's 2 hours later where you are, isn't it? So it's just gone 11 o'clock in the evening. Yeah. So once again, many, many thanks for joining us tonight and for a wonderful talk, Bob. My pleasure, David. And if you require any other sort of talks, I'm always available. Or if any of your members want further information based upon tonight's talk, I'm available via email. I'm quite happy to exchange notes. Thank you. And that's on your QRZ page, I guess. Yep, it is. Lovely. Bob, thank you very much. Very late for you, and thank you very much for staying with us this evening. Okay, my pleasure. Bye-bye. Bye-bye. There we are. Really useful talk on filters. It doesn't sound exciting, does it? You don't think our hobby was just a matter of plugging everything together and it just works, but it doesn't, especially if you've got other stations working nearby. So hopefully that information there has been really helpful to you in making stuff as well. Let's hope someone might pick up the baton and maybe continue making those kits, because they really do look good. So that's almost it for NARC Live tonight. Just to go through the programme of things that are happening in the club in the next week. On Sunday, as I said, the GB2RS News as usual at 7 o'clock on GB3MB. Also on that same repeater at 7:30 on Monday is our Monday Night Net. And then next Wednesday, October the 30th, we don't meet here online. We meet in person at CNS for a social informal between 7 and 9:30. And we'll see you here again for NARC Live in 2 weeks' time. But until then, from Tammy M0TC.
Bye-bye.
And from me, David G7RP. Thanks for joining us. Take care. Look after yourselves. Bye-bye.